job.
Muchas gracias. Muchas gracias. Muchas gracias. Muchas gracias. Thank you so much. Nice to meet you.
It's nice to meet you.
Thank you so much. Nice to meet you.
Thank you.
Thank you so much. Nice to meet you.
Thank you, sir.
Thank you so much.
Thank you.
Muchas
Muy
gracias.
bien. Muchas gracias, ¿eh?
Muchas gracias.
Porque yo que sé tan sencillito y
Es
tan... Sí, ¿verdad? Sí.
Perdón. Thank you.
He's actually being.
¿Qué tan cerca nos lo... así? Así.
Is it on? Is it on?
So yeah, I don't know.
Okay.
Oh, okay.
Perfect. Is it on? Okay, cool. Yeah. All right. Good afternoon, everyone, and thank you for taking the time to be here today. We are team from Scrap to Strategy from Mebane, North Carolina. I'm Stisha.
I'm Andrés.
I'm Dan.
And I'm Casey. All right, before we get started, by a quick show of hands, how many of you here would like to reduce your energy consumption at home? Wonderful. And we want to do the exact same thing and take this idea to our workplace. However, at the moment, ABB Mebane is the fourth highest waste producing facility. If we continue working this way, we are never going to reach our mission to zero goals. Every year, we produce 1,075 tons of material waste. This is the equivalent of 215 adult elephants in weight. That is just $2 million down the drain every year, just like that. And now, to address the elephant in the room, Andres, what even is our project about?
Now, what makes ABB Mebane so different than other facilities? Well, we're an engineer-to-order or ETO facility. Up to 40% of the switchgears that we make are custom-made. We have 70 different types of raw material across copper and steel. And the numbers for these part numbers keep growing day by day, making utilization extremely hard for us to control. And it doesn't stop there. The applications, the machines, and the tools that we have for both copper and steel are completely different. Now we realized this in the first few weeks that we got here. And we realized that we had something big. We basically had two lean challenges in one. And how do we tackle this? Well, we divided and conquered and split in two teams. Team Copper with Casey and Dan, and Team Steel with Stisha and I. And that is exactly what we're going to be doing here today. We're going to walk you guys through both of these solutions, starting off with steel. Now, being ETO for steel means that demand fluctuates week by week, and we don't know what parts we're going to be getting. We don't know what materials we're going to be getting, the thicknesses, and most importantly, the part dimensions that we're getting. Basically, leaving utilization up to luck. We analyzed historical data to see if there was any room for improvement. And with the lack of ideal jobs and the fact that our initial utilization was at 51%, meaning that half of the sheet was just wasted, we knew that something had to be done about this. But why was this happening? What was the current state? Well, for the current state, the planners would nest whatever was available from the same material and thickness and immediately send it down to the manufacturing floor with no room for utilization improvement at all. To tackle this, we developed the output board. The output board's main purpose is to combine jobs from the same material and thickness together, therefore increasing the utilization and reducing the NVA of tool setup in the manufacturing floor.
Since we are an ETO facility that is so heavily influenced by demand, every other sheet that we punch looks quite like the one on your screen right now. The highlighted red indicates how much material is wasted on every sheet. And so what did we do about this? We introduced right-size sheets. In this specific example, we were able to double the material utilization. Out of our 29 materials, for 9 of them, we now carry both the full-size and the right-size sheets. Moving on to point-of-use templates. These are our high-running parts that are punched out in the same exact formation every time we receive an order for them. Out of these 60 templates, we identified 11 of them that were severely underutilized. After making our modifications, we were able to see a 10% increased average utilization. All 3 of these solutions put together gave us a whopping 17% increase in material utilization. And that was just for steel.
All right, guys, who's ready for Team Copper?
Thank you for that intro, Dan. Of all the machines in fabrication, only one stands out for its lack of utilization tracking, the copper punch machine. This lack of visibility is extremely expensive. We spend $2.3 million per year on raw copper materials alone, with $700,000 being lost to scrap. And our biggest contributor? The copper punching machine, the one place we have no tracking and no feedback.
So guys, what makes tracking so difficult? Well, when we arrived in Mebane, we discovered a couple of clues. For one, leftover bars longer than 3 feet aren't scrapped, but they're sent to storage for later use. And remember, we're an ETO facility, so one production order probably isn't going to fill a 12-foot bar. But these clues just led to more questions than answers. So how do we answer those questions? First, we developed a utilization metric that measures the amount of bar used the first time it gets punched. We conducted exhaustive time studies with the operators on the shop floor and found that utilization to only be 53%. Guys, 53%, that is super low. Take a look at the video on the left. The operator enters the storage area just 5 times in 25 minutes to load and unload those bars by hand. We have a $700,000 robot installed to do that job for her. The spaghetti chart on the right confirms this. Her movement is concentrated in the area between her workstation and that storage area. So, big picture, what does all of this mean? Our time studies confirmed 81% of a copper punch operator shift could be classified as non-value added time. On top of this, we identified 4 major wastes of this NVA, with motion obviously being the highest at 61%.
Now, what if we were able to combine multiple orders to fill up the entire bar every time the first time around? You may not believe me when I tell you this, but the planning team already does this, yet the operators are not using them on the floor in Mebane. Why was this? Well, 95% of the nests that we tried to run resulted in an error. When this happens, the operator has to stop their work and wait on average 4.5 minutes until some member of the planning team can come help them. Even when the nests are running properly, they were extremely overwhelming. Parts come out fast in a random order with no way to identify them. What we did after solving all of these nest errors was create the nest paper, those pink pages on the right side of your screen. They give custom step-by-step instructions of what part is coming off the machine when, completely eliminating our original operator confusion.
Guys, I cannot stress enough how frustrating and repetitive fixing those nest errors was, but the impact after re-implementing proper nests was dramatic. We are proud to report we dropped NVA by 52%, and the biggest waste culprit, motion, cratered to just 16%.
And that's not our only area of improvement. We increased our utilization by 19%. And with our new nesting procedures, the operators are able to work on the parts as the machine is producing them, tripling our part output capabilities per shift. Additionally, we created the first ever real-time copper scrap tracking in Mebane. Now, every nest, every part produced, and every tool used is saved in our database. This information can be used for future improvements on the punch machines, KPIs for planners, and even AI datasets in the future.
Okay, so Kaizen, change for good, right? Our time spent in steel and copper challenged us to step into the shoes of the operators, and in so doing, we identified 13 Kaizen opportunities. So I'll highlight some here. Starting with our shine and set and order phase, I would like to highlight our small hardware Kanban system we implemented. Moving on, some Kaizens may seem small on the surface, but they mean a lot to the operators. Every Kaizen you see here was a suggestion or request that we implemented for a shop worker on the floor. Finally, visual management was huge for us. We re-entered that gantry storage area and organized every bar by material thickness and height, so when they do need to pull one, they can do so at a glance. I also want to highlight our digital inventory management system. We created this highly important system previously existed on a whiteboard. Altogether, keeping with our operator first focus, we asked them to conduct 5S audits of their workplaces before and after our Kaizens, and we're proud to report we boosted our numbers from 65 to 88%.
Safety is our license to operate here at ABB, and so we want to protect the longevity of our operators. In this example, the operator has to reach under the machine in an awkward position to pick up this bin that could weigh up to 50 pounds. Now, with the new cart that we designed and implemented, the operator does not have to bend down at all. Our next ergonomic improvement came straight from the voice of customer. Before, operators did not know when they needed a second person to safely lift a heavy piece. Now, with our Find a Friend icon, the operators are able to know if they need help easily at a glance.
We've made a huge impact on the safety side of things, and now let's talk about the environmental impact. With all of the changes we've implemented this summer, we were able to save 235 tons of material. That's about 470 metric tons less carbon dioxide emitted into the atmosphere. To further this, that's about enough carbon dioxide to power 97 homes' energy for an entire year.
Wait, Stisha, what about money?
Andres, I was just getting there. All in all, we were able to save $1.2 million. This isn't just a win for Mebane, it's a win for ABB as a whole and our planet.
But this doesn't mean anything unless we can sustain it. For our control phase, we developed control charts for both steel and copper utilization. The control chart will be able to tell us early signs of process drift, and we will be able to identify the root cause as to why we may be under our lower control limit, therefore keeping utilization as high as possible. Additionally, we develop work instructions for every single process that we made here. Now, KPIs are a big thing because what gets measured gets done. This is why we implemented this Power BI. The Power BI tracks planner utilization by day. The Power BI tracks utilization by day. This is not only shown in the offices for them, but also shown in the tier 2 meetings to help people more accountable and have utilization as high as possible always.
We've seen the impact that our changes have had here in Mebane, and we believe these solutions can be implemented all across the board at our different fabrications. For steel, 3 simple steps. Analyze your high-running materials, simulate them to find the right size sheet for your facility, and lastly, simply order these materials.
As for copper, our data collection template can be replicated to any machine in any fabrication facility. Having clean data sets tailored to the application of AI, the possibilities are truly endless. Fabrication should be a data-driven, smart department. All we have to do is be deliberate about the data that we track.
Okay, so we painted a picture for you guys, right? Now you understand some of the grind, the long weeks of data collection and analysis, and most importantly, the targets that we smashed. But enough from us. Let's hear from the operators whose lives we impacted.
Helped us out a lot by developing best practices for nesting procedures to optimize our raw copper and trading utilization, and also allowing us to operate with more lean tooling.
My experience with each intern, they were all so sweet. I love that they've made my work area much safer and neater, and also made it more possible for me to have a productive day at work.
Finally, this is our target sheet, and we're more proud to say that we not only accomplished our goals, but we went above and beyond. And we're sure that we live in Mebane leaner
and cleaner.
Thank you so much, and we're open to any questions.
So congratulations. I mean, I really like the way that you presented all the results, but also you link those with the environmental impact, and that's huge for the company and for the planet, as you mentioned. You mentioned about the right size sheet in the steel side of the savings. Was that a sheet that was already available, or you had to develop that size of sheet to fit the product that you're stamping?
We had to develop it ourselves, so we went through all the list of 30,000 parts that we had and kind of decided which would be ideal. So a lot of our parts fit 3/4 of the sheet, and that 1/4 is always wasted. And so most of the right size sheets are made to fit that custom sheet, so we could use at least 90% of it. We've also developed other standards, like such as when there's a really big hole in the middle of the part. Usually that's all scrap, but now we're gonna fit in smaller parts into there. But yeah, it's something we had to develop on our own.
Great.
Yeah.
Congratulations again.
Thank you.
Thank you.
Again, good job on sustainability. I like the numbers and the way you presented it. It's great. I think you focus on all the key metrics that we all have to have. We have at the factory. I know that you work on, improving the way that we're using the material so that we can reduce the scrap. But was there any? I know you focus on on the high using material, but was there anything else that we need to continue to work, or is there like a follow-up project so that we can continue to see these improvements and these savings?
I think for the steel side of things, in the output board, we kind of divided the bins by machine, so like 5,000 and 7,000. And something we've noticed is the fact that sometimes one machine gets a little more overloaded. One of our machines has a laser, and I think our planners tend to like that feature, and so they load most of those machines. But something we've worked with our CI manager is to kind of divide that, and that's a big area of opportunity that we've seen.
Yeah, and for copper, on those side of things, our data that we are tracking now is for those continuous improvement projects. Now, when we first came to Mebane, we had no visibility into anything happening on the punching machines. And so using the data, one thing that's really big for us is die changeovers. Those take a lot of time, and they might be happening more often than they need to be. And so now with that data, we'll be able to have visibility into what tools are being used, when are they being switched out, and possibly reducing the die changeovers in the future.
Great job. Thank you.
Thank you.
Hey, feel free to grab some swag.
Yeah. So they say our name on them.
Thank you. Thank you.
Yeah.
Thank you.
Good job.
guys.
Thank you. We appreciate your time. Yeah. Thank you so much.
Yes, I take all of it.
Thank you. That was amazing. Thank you so much.